All right, this video is for those ruler graph additions that we did in class. So if you remember on the back of your pricing system at work paper, I had you add these 4 sentences yesterday, and I gave you a little bit of time in class to be able to figure out if something is supply or demand, if it's a right or left shift, to draw the graph, and to tell me what happens to equilibrium. And I said that I would give you more time today to work on it. Well, e-learning day. What are you going to do? So here's what I want you to do is that first off, if you are not already done going through these 4 things that are spelled out at the top, then I want you to pause this video right now, finish those first, and then replay and then hit play, and I will go through the answers. Okay, so pause. All right, hopefully everybody has at least a good guess on this. So let's go through the answers. So the first one is saying you can use your iPad to graph your demand and supply curve. What the heck does that have to do with rulers? Well, if you remember when we did this, you used your ruler to be able to draw and graph your demand and supply curves. You used it as a straight line. But if I said that you could use your iPad instead of a ruler, would you need your ruler? No. So what factor is that? That substitutes for a consumer. That's related goods. So that's a demand issue. And if you could use the iPad instead of a ruler, that's going to cause your demand to shift to the left. So when you're drawing your graph, it's going to look like this. There's my demand left shift. All right, so now what happens to equilibrium, price, and quantity? So here's my original equilibrium. Here's my new equilibrium. What happened to my price going from here to here? My price went down. What happened to my quantity going from here to here? My quantity went down as well. All right, what about number 2? The cost of ink decreases. What does ink have to do with rulers? Again, if you remember when we started this, before I had anybody go and sell anything, I told them what it cost to make the rulers. And one of the things that was used to make the ruler was ink. The ink on like the ruler for the lines and the numbers and all of that stuff. So the cost of ink decreases. That's going to be a cost of inputs. And if cost of inputs is definitely supply. So if the cost of ink decreases, that's going to cause the supply curve to shift to the right. So here's what it's going to look like. So here's my right shift. And now you have to ask yourself what happens to equilibrium. So going from this equilibrium to this equilibrium. So what happened to my equilibrium price? Going from here to here. My price went down. What happened to my equilibrium quantity? Going from here to here. My quantity went up. Okay, so as a result, price goes down, quantity goes up. All right, what about number 3? So the producer expects the price of rulers to rise next week. Okay, well, there's the expectations. There's the next week. So that tells me it's expectations. But we have 2 expectations. We have one for demand and we have one for supplies. So which one is it? Because it says producers, that's telling me this is supply. And if producers are expecting the price of rulers to go up next week, when do they want to sell? Now or next week? Next week. So they're going to go and not produce a whole lot now. So this is going to be a left shift now. So supply, left shift. And then we're going to draw what happens to the graph. So here's our left shift in supply. And we have to ask ourselves what happens to equilibrium price and equilibrium quantity. So here's my original equilibrium. Here's my new equilibrium. So what happened to my price going from here to here? My price went up. What happened to my quantity going from here to here? Quantity went down. All right, last one. You get colored pencils for free with the purchase of a ruler. All right, what does colored pencils have anything to do with rulers? Well, when we did this activity in class, I said everybody needed to buy 1 ruler and 5 colored pencils. So in this instance, rulers and colored pencils kind of go together. And what is that? That's a complement. That's a related good complement. So this is telling me that this is a demand issue. I'm going to buy rulers and colored pencils. And if I get colored pencils for free with the purchase of a ruler, what happens to my demand for rulers? My demand for rulers are going to shift to the right. So here's my right shift in demand. All right, what happens to my equilibrium price and my equilibrium quantity? Well, here's my old equilibrium. Here's my new equilibrium. What happened to my price going from here to here? My price went up. What happened to my quantity going from here to here? My quantity also went up. All right, so those are the answers for those ruler graph examples. Now, you will notice that, or you should notice, that I have one example of each option. So I have a demand left, I have a demand right. I have a supply left, I have a supply right. Guess what? Anytime the demand curve shifts to the left, price and quantity are both going to drop. Anytime the demand curve shifts to the right, price and quantity both go up. Anytime the supply curve moves, price and quantity are going in opposite directions. If the supply curve shifts to the right, the price goes down, quantity goes up. Supply curve shifts to the left, price goes up, quantity goes down. You shouldn't have to memorize that. Emphasize shouldn't. Because if you draw it, like we did here, you can figure that out as long as you know there are factors. All right. Now we're going to look at what happens if both supply and demand move at the same time. So you need to pull out your regular notes, and we're going to talk about that. So changes to equilibrium when supply and demand change at the same time. All right, here's what I'm going to tell you is I'm going to draw this out, and I'm going to start with my supply and demand curve, and notice that I have E1 as my first equilibrium. Your choice in whether or not you want to draw the four options of graphs. I will tell you that I'm going to go through it, and if you need to pause the video because I'm going too fast and you need to draw and whatever, go right ahead. That's part of the wonderful geniusness of videos. Okay, so first option we're going to look at is what if both supply and demand shift at the same time to the right? So what if, for example, the supply curve shifts to the right and because of, for example, the cost of inputs goes down, or the price of a substitute goes down, or the price of a complement goes up, or there's better technology, or there's more sellers, or the producers are expecting a lower price in the future. Any of those will cause a right shift in supply. And at the same time, the demand curve shifts to the right. So maybe this is because income is increased. Maybe people just like the product better. Maybe the price of a substitute is going up, or the price of a complement is going down. Maybe there's just more consumers in the area, or maybe consumers are just expecting a higher price in the future. Either way, right shift in demand. Now, notice I have a new equilibrium. So my new equilibrium is where my new supply curve intersects my new demand curve. So that's here. So I'm going to call that E2. Now, what happened to my equilibrium quantity? So start with quantity. So going from here to here, my quantity increased, right? That's pretty easy. Well, what happened to my price? Well, if you think about it, my price, the way I drew it, my price actually went down slightly. But what happens if I do something different where, what if I go and draw, I'm going to draw a quick one here. I have a supply and I have demand curve. By the way, this is not easy to do with my finger on the trackpad. What if I do where my supply curve shifts here? Here's my right shift in supply, and here's my left or my right shift in demand. So here's my original equilibrium. Right? Here's my new equilibrium. In this case, the way I drew this, what happened to my equilibrium price? Kind of went up, didn't it? So what's the difference between this lovely, crudely drawn purple drawing and this one over here? Why is it this one has an increase in price, this one has a decrease in price? Hopefully you noticed that the difference is that here I shifted the demand curve more. Here I shifted the supply curve more. My point is that when both demand and supply change at the same time, you can't tell one of these, what happens to one thing, either the price or the quantity. And so in this instance, when they both shift to the right, you can tell that quantity increases, but the price change is unknown. You don't know what happens to the price because it depends upon what's the bigger shift, the supply shift or the demand shift. So, as a result, there we go. When demand and supply both shift to the right, quantity increases, but the price change is unknown. So now, what happens if they go the opposite direction? So what if supply curve shifts to the left? So this could be because the price of inputs goes up, the price of a substitute goes down or up, the price of a complement goes down, there's worse technology, there's less sellers, or if producers are expecting a higher price in the future, that'll cause a left shift. And at the same time, the demand curve shifts to the left. So people have less money. People just don't like this product. The price of a substitute goes down. The price of a complement goes up. There's less people in the area, or if consumers are expecting a lower price in the future. All of that will cause a left shift. So now we find our new equilibrium, where our new supply curve and our new demand curve intersect, which is there. And I labeled it E3. So what happened to my quantity? So going from here to here. My quantity obviously went down, but my price, again, is unknown. Why? Because I don't know which curve shifted more, the supply curve or the demand curve, or was it an exact even trade, in which case it didn't move at all. So when the supply and demand curve both shift to the left, the quantity is going to decrease, but the price change is unknown. I just don't know what's going to happen. All right, what if we split the difference? What if we go, one goes one way, the other one goes the other way? So let's try this way. Let's have the supply curve shift to the left. Again, maybe the cost of inputs goes up, maybe the substitute product price goes up, the price of a complement goes down, there's worse technology, there's less sellers, or producers just expecting a higher price in the future. Again, left shift in supply. And at the same time, the demand curve shifts to the right. So maybe consumers have more money. Maybe consumers just like this product. Maybe the price of a substitute item is going up. The price of a complement is going down. Maybe there's more consumers in the area. Or consumers are just expecting a higher price in the future. Either way, right shift in demand. So now we have a new equilibrium, and it's here. So what do we know and what is unknown? Hopefully you can see, going from E1 to E4, our price is definitely increased. But again, you don't really know what happens to the quantity. Why? Because you don't know what's the bigger shift. Is the demand curve shifting more, or the supply curve shifting more? Or is it kind of like the way I drew it, where they're basically even? So when the supply curve shifts to the left and the demand curve shifts to the right, the price is for sure going to increase. But you don't know what happens to the quantity. All right, obviously there's one option left. What about if we do the other direction? What if our supply curve shifts to the right? So maybe, for example, the cost of inputs has gone down, or the price of a substitute has gone down, or the price of a complement has gone up, or there's better technology out there, or there's more sellers, or the producer is just expecting a higher price in the future. Either way, supply curve shifts to the right. And at the same time, the demand curve shifts to the left. So maybe consumers have less money. Maybe the price of a substitute is going down. Maybe the price of a complement is going up. Maybe people just don't like this product. Maybe there's less consumers out there, or they're just expecting a lower price in the future. Either way, left shift in demand. And as a result, here's where my new equilibrium is. Now, this one's slightly off, but you can see that going from E1 to E5, what happened to my price? Well, my price obviously dropped. What happened to my quantity? Quantity is undetermined because, again, we don't know which one's the bigger shift, the supply shift or the demand shift, or are they exactly equal? So when supply shifts to the right and demand shifts to the left, then the price is going to decrease, but the quantity change is unknown. Notice kind of the theme here is anytime you have a double shifter, you're going to know one of these, either price or quantity, and the other one is going to be unknown. Now, how do you know if an example is a double shifter, for example, on the test? Well, they're going to literally say, blah, 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 blah happens, and this other thing happens. So they're going to give you two separate examples. That's when you know it's a double shifter. Okay? Otherwise, you can assume it's just a single shifter. All right, that's it about changes in equilibrium. Please let me know if you have any questions.